Good evening, everybody. I hope all of you have stayed warm over the course of this chilly weekend. And on a more serious note, I'm here yet again to help y'all with this next unit of homework. So let's not waste any time. Let's get right into your homework for Unit 4. Now, as always, I've done my own set of problems and I've worked through them to help y'all. Let's get going. For the first question about the four shapes, you want to take one of the shapes and that'll serve as your base. For example here, we're going to start off with the hexagon as our base. Now you want to take the trapezoids, the triangles, and the rhombuses, also pronounced as rhombi depending on how y'all look at it. And you want to see how many times the other shapes can fit into your base. In this case, we take the trapezoids and we see that 2 trapezoids fit into a hexagon, 6 triangles fit into a hexagon, and 3 rhombuses fit into a hexagon. Similarly, if we take a trapezoid, we could see that a trapezoid goes into half a hexagon, 3 triangles go into a trapezoid, and 1.5 rhombuses go into a trapezoid. For the triangle, we can see that it represents 1/6 of a hexagon, goes into 1/3 of a trapezoid, and half of a rhombus. And lastly, a rhombus. It goes into 1/3 of a hexagon, 2/3 of a trapezoid, and 2 triangles can fit into a rhombus. So basically, the whole idea here is that you want to take one of the shapes, and that serves as your base. Once you have that base, you're looking at the other shapes. You want to see how many of those other shapes can go into your base, like with the hexagon, how many triangles can go into it, how many rhombuses, etc., so on and so forth. From there, it's just simply representing it as a fraction. If you can get that concept down, you'll be doing fine on that question. Alrighty, for the next one, it's about the worker with a length of rope. For this problem, it's 72 feet for my work, so after we take out the work, we are down to just simply 36 feet. Now, he had to get rid of 25% of his rope after the first project. He used 25% of that for the second project to get down to 36. So with that in mind, we know that we're looking for some number that when you take away 25% of it will get you down to 36. That number is 48, which means he had 48 feet of rope left after he completed the first project. Now let's take that knowledge and fill out the second part. Now we know he has 48 feet of rope, and before he did anything with it, he used 33% of the rope to get down to 48 feet. As a result, we're looking for a number, yet again, that when you take away 33% of it, goes down to 48. We find out that this number is 72. As a result, we now know that he has 72 feet of rope when he started his project. So this can be approved. We can double check this by doing the math. As we demonstrated, take away 1/3 of 72 to get 48 and 1/4 of 48 to get to 36. And the goal here is to recognize, I want you guys to kind of backtrack. You know what he ends up with. But what I want you guys to realize is that if you take the percentage and use that sort of logic to kind of get a variable and work around it, you will eventually find out that number, you'll find a number that you originally started with, like finding 25% of 36 is what we got to 48. And we used that to find out that we had 72 feet of rope. Now for the third set of questions, this is kind of just, you're representing the goal here. I want you guys to recognize that adding fractions really is no different than adding numbers or integers, just in a different form. So here we've got our whole square, and then we're just simply adding 1/3 of that and then half of that to get our final answer here, which is 5/6. Yet again, we're adding 1/3 on the number line and then 1/2 on the number line to get to 5/6. For part B, yet again, 1/2 and 3/4 So 1/4, 2/4, 3/4, 4/4, and 5/4. The answer here is 5/4, which is a little above the whole mark. And yet again on the number line, 2/4, and then 3/4, 4/4, and 5/4. Now we get to subtraction. This one's a little bit tricky to kind of represent, but if we got, for this one, I'll be okay if you guys kind of just stack it to the right. That's going to be the key to recognizing the difference between subtraction and addition. And then we recognize, start off with 3/4 of a whole, take away a third of it, and then 1, 2, 3, 4, 5 twelfths is what we're recognizing with, because the common denominator here is 12. So we started off with about 3/4 or 9 twelfths, and then we got rid of 4 twelfths to get rid of 5 twelfths. See, the easier thing to do is going to be working with this number line. And then yet again, 3/4 minus 3/6. 3/6 is the same thing as 1/2, or 2/4. So 3/4 minus 2/4, it's going to be 1/4. So we showed that here on the number line as well. 3/4, and then take away 1 and take away 2/4 to get 1/4. For the fourth question, this time we're going into multiplication of numbers. And do you remember when you just multiplied a number, say like 4 times 3, you just going 4 digits, 4 to the right of 0, 3 times? Well, that's pretty much the same concept here with the multiplication. You're just going 1/5, in this case, a fifth to the right of 0, 3 times. So 1/5, 1/5, and 1/5. So you can just add those up together, and you'll find that your answer is 3/5. And we demonstrate that here on the number line as well by showing that we go to 1/5 once, twice, 3 times to get our final answer, 3/5. So now for the second question, 3 times 2 over 4. Again, we're going 2/4 or 1/2. You can simplify it to 1/2. 3 times. So 2/4, 4/4, 6/4. So of course, add those up, you get 6 over 4. And yet again, here on the number line, 2/4, 4/4, 6/4, which you can be simplified to 3/2 or 1/2 if you need to simplify it. And here we are again, 5/8, doing it 5 times. 1, 2, 3, 4, 5. So add 5/8 up 5 times and you get 25/8. So in this case, we'll represent that with 3 wholes and then 1 1/8. This can also be represented as 3 1/8 in mixed number form. And we, of course, represent that on the line too. 5/8, 10/8, 15/8, 28, 25 over 8, or 3 1/8. I prefer mixed numbers, but you can do either or. I'll accept credit for those. And so I forgot. We're going to be working with negative numbers here as well. So here's the thing. It's the same concept. Only difference is you're going to be left of 0 because here we're working with negative numbers. But other than that, it's the same thing, and you can recognize them as pretty much the same thing. So yet again, 5/8, 5/8, 5/8. Only difference is we're subtracting because we need to go to the left of 0. So our final answer will, of course, be negative 3 1/8 as well. And see, here it is in better view. We're going to the left. So negative 5/8, negative 10/8, 15/8, negative 28, negative 25 over 8. So same thing, you're just going to the left. So my goal here is to recognize that multiplication doesn't change. You're still just going to the left or to the right, left or the right of a certain distance a certain amount of times. It's just that you're working with non-integers instead. Next up for number 5, we have a square and we're trying to figure out how much of it is represented in each of these little portions. Now you kind of have to do a combination of 2 things. The key here is to do a combination of 2 things. Number 1, you kind of want to start eyeballing it and see kind of if you can make a guess. Based on eyeballing, you can infer that square A is about 1/4 of the whole square, or triangle A is about 1/4 of the whole square. But from there, we can also see that, hey, square triangle A and triangle B have the same number of hash marks, 2 singles. That means they're both about a fourth of the whole entire area. Now, once again, I'm looking at, let's look at F and G. Let's look at G. So if we were to draw a line here, imagine drawing a line at about the middle of triangle A or B. Now that would be, since that is about, the A and B are a fourth of the area. If we split them in half, you can kind of eyeball and see that half of that would be an eighth. And that's kind of about what G would be. So we know that G is an eighth, and then yet again, F and G have that same set of hash marks. So we know that both of those are an eighth. And then E, once again, split in half, E and C are about shorter than that. So we can assume that's about 50% of that if we split the triangle up in half. And we can infer that triangle C and E are about a 16th of the area. And then our last remaining object is D. Since we've covered up 7/8 of the object, this means that box D has to be an eighth of the area in order to fill up 100% of our square. So basically, the goal here is to do two things. Use your eyeballing skills to realize how much of a square is represented. Excuse me. And then once you know that, use those hash marks to help you do a little elimination of process of elimination to help you get closer to filling the area of the box. Now for the final question, for the one about the baking, brownie baking, the goal here is just to realize that you need to realize what portion, what percentage or fraction of the brownies you are not going to bake, and then translating that to the rest of the ingredients. So it's originally meant to serve 16 brownies, but we only need 12. So let's do a little equation. 16 minus x equals 12. Subtract 12 from both sides, and you learn that x is equal to 4. So the difference between 16 and 12 is 4, which is 25%. 4 is 25% of 16. With that in mind, you can now subtract 25%, or 1/4 in fraction form, from the ingredients to get your final amount of ingredients that you need to serve your 12 brownies. So 25%, take away 25% from a third, gives you a 1/4 cup of butter. Take away 25% of 3 to get 2 1/4 ounces of unsweetened chocolate. Take away 25% of 3/4 to get 9/16 cups of sugar. Take away 25% of 1 1/2 to get 1 1/8 teaspoons of vanilla. So get rid of 25% of 2 gets you 1 1/2 eggs. And taking away 25% of 2/3 gets you 1/2 cup of flour. Again, the main goal here is to realize that you need to see how much food you're not going to be serving, and then once you realize that difference and get it to percentage form, you can translate that to the ingredients. Realize that, and you'll get the points on that problem. And that concludes my lesson tonight. I'm glad to help y'all, and if this doesn't do enough and you need to get some more help, I'm here for you. We'll take some time and I'll answer any questions y'all have. In the meantime, thank you guys so much for your attention. I can't wait to see y'all real soon.